Now we are going to take a look at the ADM. ADM stands for the average distance from the mean. So again, the idea here is we want a typical distance. We want a typical distance from the mean. And the easiest way for us to come up with what we consider to be typical is to simply find the average. So we will find the average. Find the average distance. So the way we go about calculating the ADM, we have, say, our dot plot. And the first thing we need to do is simply find the mean. In this case, our dot plot is symmetric about the 5, so it turns out that 5 is the mean. So this is our mean, or our x bar. From here then, we need to find how far each of the points is from the mean. So find each point's distance from the mean. So for each point, for example, if I pick this point right here, we are going to calculate how far away it is from the mean. So I meant for that point to be at 7. So this is 7 minus 5, or 2 away from the mean. And so we will find that distance for every single point, figure out how far is each point from that line for our mean. Once we have done that, then we will average all of those distances. So I have a data set here, 4, 6, 3, 8, 2, 5, 6, 7, 4, 5. Our job is to calculate the ADM. Again, the first thing we need to do is simply find the mean. To find the mean, we are going to add them all up and divide by the number of data values. So we have 4 plus 6 plus 3 plus 8 plus 2 plus 5 plus 6 plus 7 plus 4 plus 5. And then we will divide by the number of data values. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data values. If we add up the top, 4 plus 6 is 10, plus 3 is 13, plus 8 is 21, plus 2 is 23, plus 5 is 28, plus 6 is 34, plus 7 is 41, plus 4 is 45, plus 5 is 50. So we are looking at 50 divided by 10, or in other words, our mean is 5. Next up, we want to find the distance from each point, or distance between each point and the mean. We can either do this on the dot plot and visualize it, figure out how far away each point is from the mean, or we can just do the subtraction ourselves. I'm going to take a look at a dot plot. So our points were at 4, 6, 3, 8, 2, 5, 6, 7, 4, and 5. Turns out I did actually just make a symmetric data set there, symmetric about 5, so it does make sense that 5 is the mean. Let's go ahead and put our line through our mean at 5. So these 2 points here, these 2 points right here, are right at the mean. So they're 0 away from the mean. So these 2 points are distance 0 from the mean. Then the next 2 points, going from 5 to 6, we're just going 1 away. And distance between 4 and 5 is also 1. So these 2 points here, as well as the points over here, are all distance 1. Next up, we have from 5 to 7 is 2 away. Distance between 3 and 5 is also 2. So we have 2 points that are distance 2. And finally, these last ones are distance 3. So if I wanted to take the mean, we still have 10 values we're looking at, but now we're just studying the distances. So that was finding the distances. Next up, we are going to find the average distance. So we had 2 points that were 0 away. So our ADM. We have our 2 points that were 0 away. We had 4 points that were 1 away. So we'll add in 4 ones. We had 2 points that were 2 away. So we will add in 2 2's. There's our 2 distance 2's. And then actually, I'm going to color code. So our distance. Okay, I went back through and just color coded. So we had our 2 distance 0, our 4 distance 1, 2 distance 2, and 2 distance 3. So I add up all those and then divide by our 10 values, or the fact that we had 10 of these. If we put this all together, that's 4 plus 4 plus 6. So that's looking at 14. My daughter really wants to join in. All right, so we have 4 plus 6 is 14 divided by 10. So our average distance from the mean is 1.4. So the ADM is 1.4. So that means that our typical distance, we're about 1.4 away from the mean, about 1.4 away from the mean. So those 4 points outside balance out those 6 points that are within that distance from the mean. All right, so that's our ADM. We will play around with the ADM some more in the next video.